Hello everybody. In today's video we'll be talking about the energy changes during chemical reaction. Now just to remind you that in a chemical reaction we have the reactants and the products. Now the reactants, they form the products under a certain energy. They require a certain energy called activation energy to form the products. Without that energy it is difficult for the reactants to form the products. Now I just wanted to focus on several terminologies so that they can help us to understand this concept very well. Now the first terminology, that is the activation energy. I know this is very common, which is the minimum kinetic energy required for a chemical reaction to take place. We also have the spontaneous and the non-spontaneous reaction. To differentiate this, the spontaneous reaction, it is a reaction in which the reactants themselves, they can form the product without being supplied with energy. Whereas the non-spontaneous reaction, it is a reaction in which the reactants, they cannot form the product without them being supplied with activation energy or the minimum energy. Now we also have what we call a catalyst. A catalyst is a substance that changes the rate of chemical reaction. Now I want us to talk about the heat of reaction or enthalpy. This is quite important under this concept. Now the enthalpy, as denoted by delta H, is the net change in energy in the chemical system when a chemical reaction takes place. Now it can be expressed in a formula where we say delta H is equal to the energy of the product minus the energy of the reactants. Remember, the delta H, because it's an energy, it is measured in kilojoules per moles, not in joules normally as I've written here. It needs to be corrected and it becomes kilojoules per moles. Now we also have the two familiar concepts, that is called endothermic and exothermic reaction. Now to differentiate between the two, I always tell my students that the exothermic, if you go to the word exo, it means outside, it means to release. While the endo, it means inside, it means to absorb. Therefore I will say the exothermic reaction is the release of energy, while the endothermic reaction is the absorption of energy. Now what happens during these reactions is that during exothermic reaction, the energy of the reactants is greater than the energy of the products. Whereas under the endothermic reaction, the energy of the reactants is less than the energy of the products. What happens to delta H is that we go back to the equation that during exothermic reaction, it says the energy of the reactants is greater than the energy of the product. Therefore remember, the delta H, it is the energy of the product minus the energy of the reactants. Now it means if the energy of the reactants is greater than the energy of the products, it means delta H will be less than 0 or negative. Therefore that reaction, we call it the exothermic reaction. But in terms of the endothermic reaction, because the energy of the product is greater than the energy of the reactants, now we say the delta H will be positive or greater than 0. Now some of the equations, they have been shown there. You see at the end of the equation they say delta H is equal to minus 226 kilojoules per mole. Remember, the units for energy is kilojoules per mole, as I've already mentioned previously. Now the moment you see negative 226, you know that there has been a loss of energy, because we have a negative value, or we have a less than 0 value or value of energy. Therefore we know that this is what we call the exothermic reaction. But where we have delta H being positive or greater than 0, then we know that the reaction is endothermic. Now let's look at the graphical expression of these two concepts, endothermic and exothermic reaction. We know that this side is the energy increases on the y-axis. It increases as you go up through the y-axis. Now what happened is that we start with the reactants. Now the reactants, they have been supplied with the minimum energy. It is also known as the activation energy. To a certain level it rises to a certain level. Now the graph rises to a certain level until a peak, okay, while at the peak then it drops. But remember, here under the endothermic reaction, it doesn't drop until below the reactant's energy. It becomes above. Therefore, it means the energy of the product is greater than the energy of the reactants. No, I'm sorry. It means the energy of the product is greater than the energy of the reactants. Yes. So it means delta H in this case is positive or greater than 0. Now in terms of exothermic reaction, as you can see, we start with the reactants. We also supply it with the activation energy or the minimum kinetic energy for the reactants to form the products. But interestingly here is that we have the products being formed with a lower energy than the reactants. Therefore, it means the energy has been lost here. There has been a release of energy. That's why you see the products having low energy than the reactants. It means the delta H in this case is less than 0 or is negative. I hope you enjoyed the video. I will ensure that I paste another video on the questions that are normally being tested to the grade 12 learners, so that you excel in this concept. Thank you very much for listening, and don't forget to subscribe to our channel.